Hi everyone, in this video we are going to solve a compound linear inequality where we have two linear inequalities combined together, right? So what are those? Well, in this example we have one linear inequality right here, so let me underline that, and then another linear inequality that we have, and that is right here. It is actually right here. So from here up to this, right? So the green underline, that is one linear inequality, and the white underline, that is the other linear inequality. So when you are given a compound linear inequality like this, the first thing you want to do is you want to isolate them into two separate linear inequalities or two separate simple linear inequalities, right? So let's do that first. So first we are going to create two linear inequalities from this given condition. So the first linear inequality would be the first portion, which is, and this should be marked as equation number 1 or inequality number 1 rather. So I'm marking it as inequality number 1, and then the other one is, and we're going to mark it as inequality number 2. And one important thing you must remember is that there is an AND condition. That means both of the inequalities have to be satisfied. For whatever solution that we find for x, both inequalities have to be satisfied. So there is an AND condition. So I'm writing it clearly right here. So this is an AND condition, and we must remember that this is very important. That when you have a compound inequality, when you isolate them into two separate inequalities, you must remember that there is an AND condition. That means for any solution that you find, both inequalities have to satisfy. So now let's try to solve one by one. So first we are going to solve the first inequality. So from the first inequality, what do we get? So from here we get, and then from there what do we get? Let's multiply both sides by 10. That way we can get rid of the denominator, because the LCM of 10 and 2, the LCM would be 10. So let's multiply both sides of this inequality by positive 10. And because we are going to multiply by a positive number, the inequality sign will not change. It will remain as the less than sign. So let's do that then. Let's multiply both sides by 10. And then let's simplify a little more. So from here we get, and then from there we get, and from there we get. So from the first inequality we get x less than 5. That's our solution for the first inequality. So let's highlight that. Now let's solve the second inequality. Here also we want to get rid of the denominators, and the LCM of the denominators would be 10, 2 and 5. So the LCM would be 10. So let's multiply both sides by 10, and because we are going to multiply by a positive number 10, the sign of inequality will not change. So let's multiply both sides by 10 then. So if we multiply both sides by 10, then we get, and if we simplify this, we are going to get, and if we simplify further, we are going to get, and from there we are going to get. And if we now multiply both sides by a -1, or rather if we divide both sides by -2, then what will happen? Because we are going to divide both sides by -2, the sign of inequality will change, because we are doing a division with a negative number, right? So the sign of inequality will change. So now we are going to divide both sides by -2 and see how the sign of inequality is changing. So we had to flip the sign of inequality. So now we are using greater than or equal to, right? And if we simplify further, then we are going to get, and this is our second solution here, or rather the solution from the second inequality. So from both these solutions, we have to find the combined solution, meaning we have to find a solution set for which both the inequalities will be satisfied. So let's plot them on the real number line. So when we plot them on the real number line, we have one solution set which says less than 5. So less than 5 would go all the way to -infinity, and I have put a hollow circle around 5 to indicate that 5 is not included in the solution set. And the less than 5 zone would be like this. I'm going to use a red color line here. The less than 5 will look like this. And then what would be the zone for the greater than or equal to -4? Well, that is going to look like this. That will be from -4 all the way to +infinity. So I'm going to use a white color line. And now what is the common zone here on the real number line? What is the common set of solution that would satisfy both, meaning both the lines or both the solution sets overlap? That will be between -4 and 5. So let me kind of highlight that like this. So I'm going to use like a yellow color maybe right here. So I'm going to, so this is the common portion on the real number line where both inequality would satisfy, because this is the overlapping portion of the solution set. that will be between -4 and +5. So this is the overlapping portion of the solution set right here. So then how we are going to write the solution set then? Well, we can do it like this. So from here we can say, okay, x must belong to the set of real numbers which is between -4 and +5. Now -4 is included in the solution set because of the equality sign there. X is greater than or equal to -4. So -4 is included. So I'm going to say, okay, -4 is included. And how far we go? We go up to +5. So -4 comma +5. But is +5 included in the solution set? The answer is no. Why? Because in our first solution set we had x strictly less than 5. So 5 should not be included in the solution set, right? So now here we will say, okay, 5 should not be included. Then we are going to use a parenthesis. So this is how our solution set would look like for this combined linear inequality. I hope everything made sense. Thank you for watching. See you in the next video.